Hello and welcome to Anton Math. Now, we're just starting off with this video, Chapter 7, Trigonometric Identities. Now, in this chapter, we're going to be looking at the trigonometric identities we've learned so far, plus we're going to be adding a lot of new trigonometric identities, and we're going to be learning how to use these to really deal with trigonometric expressions and equations in a very nice way. We're going to deal with expressions in terms of simplification, and equations we're going to be able to verify and prove new identities using these methods, or we're going to be able to solve equations in X, just like we did in a pre-calculus 1 or algebra class. When we had equations just in X, we can do the same thing now with trigonometric equations that have X in the argument. Now first, let's take a quick look at the trigonometric identities that we've learned so far. So we're going to call these our fundamental trigonometric identities. So we have our reciprocal identities. We know cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent, and of course with these first three there's kind of some hidden identities in here as well. If cosecant is 1 over sine, that also gives us, just by doing a little bit of algebra, that sine is equal to 1 over cosecant. We also have cosine as 1 over secant, tangent is 1 over cotangent. So we have those extra identities which aren't written here, but that are sometimes useful to use in that opposite direction. Now in addition to those, we also have that tangent of x is sine over cosine, and because of our reciprocal identity for tangent and cotangent, that gives us that cotangent of x is cosine over sine. So we've seen all of these ones before, but just a quick review. We have our Pythagorean identities, and remember we've proved these already in two different ways, depending on if x is a real number or if x is an angle, and it turns out these identities are the same no matter what x is, an angle or a real number. So we have that sine squared x plus cosine squared x is 1. Remember, if we take this first identity and divide both sides of it by cosine squared, we get tangent squared x plus 1 is equal to secant squared x. And again, if we take this first identity and then divide both sides by sine squared, we get 1 plus cotangent squared of x is cosecant squared of x. We also have our even and odd properties. Remember, sine and tangent are odd, so that means that sine of negative x is equal to negative sine of x, and tangent of negative x is equal to negative tangent of x. Cosine, on the other hand, is an even function, so cosine of negative x is equal to positive cosine of x. So this is how we deal with negatives in the argument. If we ever have a negative argument that we need to change, we can either pull the negative sign out to the outside of the function, if it's an odd function, or the negative sign we can just kind of make it go away by using the properties of an even function, if that's the case. Now, of course, sine is odd, so that also gives us that cosecant is odd, right? Cosecant of negative x from our reciprocal identity is 1 over sine of negative x, which is 1 over negative sine of x from my even odd property of sine, which is negative cosecant of x. So in other words, this even and odd property for sine carries to cosecant, this even odd property for cosine carries to secant, and this even odd property for tangent carries to cotangent, even though we don't usually list those out. Now we have a couple of new identities that we're going to introduce in this video called the cofunction identities, and these can be very useful, especially when you're trying to solve out kind of a difference, or if you want to be able to write one function in terms of another one. We have that sine of pi over 2 minus u is cosine of u, tangent of pi over 2 minus u is cotangent of u, secant of pi over 2 minus u is cosecant of u, cosine of pi over 2 minus u is sine of u, cotangent of pi over 2 minus u is tangent of u, and cosecant of pi over 2 minus u is secant of u. So you can see why we call these the cofunction identities. Notice that all the identities with sine turn into cosine or come from cosine and turn into sine. Tangent has this relationship with cotangent in both directions, and secant has this relationship with cosecant in both directions. Okay. Now we have these identities at our disposal, and we're going to work out some problems now to kind of see how we use these identities in some of these problems. And in the subsequent sections, we'll be introducing more identities, doing more problems to practice with those, etc., until we get to the last couple sections where we'll be dealing with those equations that I referred to already. So let's take a look at some examples of how we can use these identities to solve some homework type problems. Or a lot of these simplification problems actually are something you might see as a middle step for a larger problem. So for example, simplify cosine t tangent of t. So I have cosine of t times tangent of t. Now I want to use one of my identities from the last page, and if you don't have them right in front of you, I do recommend that you go back to the previous page, either take a snapshot so you can have it up on your computer, or make sure to take this down in your notes so that you can have these in front of you while you're doing these problems until you get comfortable enough that you don't need to use your notes anymore. So first, I need to decide what I can do with this expression that's going to help me to simplify. Now I have a cosine and a tangent. Cosine and tangent, I can't really do anything right away, but I know that I can write tangent in terms of cosine and sine from my reciprocal identities. So let's take a look at that and see what happens. This becomes cosine of t, and then tangent becomes sine of t over cosine of t. And this is much easier to deal with. We can see right away I'm multiplying cosine to sine over cosine. So the cosines are simply going to cancel out, and this resolves into sine of t. All right, so very nice simplification. If you ever get down to just one trig function, you know that you're going to be done. It's not going to get any simpler than just having one trig function. If you get down to just a number, even better. If you have something like cosine squared plus sine squared and you get 1 at the end, that's even better than having a trig function. But if you get down to just a single trig function, that's usually our goal. Sometimes we won't be able to do this, but oftentimes this is going to be what we're going to try to do. Try to get it down to one function, or at least as close to that as we can. So that was a simple example. Let's look at something a little bit more complicated. Say I want to simplify 1 plus sine of u over cosine of u plus cosine of u over 1 plus sine of u. So 1 plus, I'm going to choose a different color. This is a little bit hard to see for you, I think. So I have 1 plus sine of u over cosine of u. I'll leave a little space here, plus cosine of u over 1 plus sine of u. Now I'm adding two fractions together. If we want to simplify this, really we should be trying to make this just one term. So our first step here, if we're adding two fractions, is to combine those fractions into a single fraction. Now that, of course, means we need to get a common denominator. So to this first fraction, I need to multiply the top and bottom by 1 plus sine of u over 1 plus sine of u. And looks like I missed my u here. And to get a common denominator on this right side, I need to multiply the top and the bottom by cosine of u over cosine of u. Okay, that gives me a common denominator. Here I have 1 plus sine of u times 1 plus sine of u. So that's going to give me 1 plus sine of u, the whole thing squared. On this side, I have cosine u times cosine u. That's going to give me a plus cosine squared u. And this is all over my new common denominator, cosine of u times 1 plus sine of u. Now I'm not going to multiply this cosine through. This is actually in a nice form where it is right now. This is going to allow us to look for some cancellations, hopefully. And up at the top here, I want to try to find a way. I see I have no cancellations. I can't cancel anything in a numerator with the denominator. I have no negatives in the top, so I'm not going to be able to cancel anything that way. So I want to find a way to use one of my identities that's going to simplify this top. Now it's not apparent what I can use right away, so let's go ahead and expand this 1 plus sine of u squared. So on the top I have 1 plus 2 sine of u plus sine squared of u. So this is all coming from that 1 plus sine of u squared. I still have this cosine squared of u all over cosine u times 1 plus sine u. Okay, so take a look. If you want to try to figure this out for yourself and you haven't seen it, go ahead and pause the video so you can figure it out. And for all of these sections, I do recommend that you pause the video, try to figure out these problems on your own, and then follow along with the video to see if you did it right, see if you get the right answer. Maybe you find a different way than I do it to solve the problem, and that's great if you do. But here we see we have sine squared plus cosine squared. This is our basic Pythagorean identity, so I can substitute in 1 here. Sine squared plus cosine squared is equal to 1. So I have 1 plus 2 sine u plus 1 from my Pythagorean identity, all over cosine u, 1 plus sine u. Let's go ahead and put these ones together. So this is 2 plus 2 sine u, all over cosine u, 1 plus sine u. So now we've simplified as much as we can. Now we need to try to get a little creative. What can we do to try to simplify this a little more? Well, I see I have a common factor of 2 in both terms of my denominator. So let's go ahead and factor that out. And on the top I'm going to have 2 times 1 plus sine of u all over cosine of u times 1 plus sine of u. And there we see now we're in a really great place because I have 1 plus sine of u on the top, 1 plus sine of u on the bottom in these products. So I can go ahead and cancel this entire 1 plus sine of u on the top and bottom. And I get 2 over cosine of u. Now we're down to one trig function, but we can actually simplify this a little bit more so that we don't have a quotient. 2 over cosine u, that's the same thing as 2 times 1 over cosine u, or in other words, 2 secant of u. We're all done. So we have this complicated thing up here at the top, and this whole thing simplifies all the way down to 2 secant of u. Okay, now we're going to do some more of these, and actually we're going to be introducing a new type of problem in the next video, so we'll see you there.